Have you ever wondered why some developers choose Python while others swear by C, or why game engines are built with C++ but websites with JavaScript? Today, we're diving into the fundamental division in programming: high-level versus low-level languages. Every programming language exists somewhere on a spectrum. At one end, you have languages that speak almost directly to computer hardware. At the other, languages that read almost like English. This distinction shapes everything from performance to developer experience. High-level languages like Python, JavaScript, and Java prioritize human understanding. They handle memory automatically, provide rich built-in functions, and shield you from the complexities of hardware. Writing 10 lines of Python might accomplish what takes 50 lines in C. Meanwhile, low-level languages like assembly and C give you direct access to computer memory and hardware operations. Every instruction translates to specific CPU operations with minimal abstraction. This power comes with responsibility. You manage memory yourself and handle hardware interactions directly. But here's where it gets interesting. This isn't just about syntax preferences. These differences create profound trade-offs that shape entire industries. Consider three critical dimensions where these language types diverge. First, performance. Netflix engineers once rewrote a critical algorithm from Python to C, achieving a 70x speed improvement. Why? Low-level languages eliminate intermediaries between your code and the hardware. When milliseconds matter, in game engines, operating systems, or high-frequency trading, low-level languages dominate. Second, development speed. A team building a machine learning prototype might accomplish in 2 weeks with Python what would take 2 months in C. High-level languages handle memory management, provide powerful libraries, and require fewer lines of code, dramatically accelerating development cycles. Third, hardware interaction. Embedded systems programmers writing code for microcontrollers and smart devices must use low-level languages. You simply can't write efficient firmware for a pacemaker or satellite in Python. The hardware constraints are too severe. Now, here's something counterintuitive that experienced developers understand. The line between high and low is blurring. Modern C++ incorporates many high-level features. Meanwhile, Python libraries like NumPy achieve near-C performance for numerical computing through optimized C extensions. This reveals a fascinating pattern. The most powerful systems often combine both approaches. Instagram's backend uses Python for rapid development, but relies on C extensions for performance-critical operations. iOS apps use Swift's high-level features while accessing low-level C libraries when needed. Perhaps the most valuable insight isn't choosing one approach, but understanding when to transition between them. Start prototyping in high-level languages for speed and clarity. Then, selectively optimize critical paths with low-level code for performance, following the classic wisdom that premature optimization is the root of all evil. The future belongs to developers who can navigate both worlds, writing clean, maintainable high-level code while understanding enough about low-level execution to make intelligent performance decisions. This hybrid approach, combining human-friendly abstractions with hardware-aware optimization, represents the true mastery of the programming craft. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.